Today we are going to see about the stresses in the spring. Okay. In the stresses in the spring is having axial force W. The spring is having axial force W, which is along the axis of the spring. Now look at this first figure. In the first figure, you will find that there is a load W. There is a load W which is acting at the axis, along the axis of the spring. We are interested in the diameter of the wire because this is the dimension which is important here, diameter of the wire. स्प्रिंगची जी वायर आहे ज्याच्यापासून स्प्रिंग तयार केले ते डायमीटर आपल्याला डिझाइन मध्ये काढायचं असतं. सो द डायमीटर ऑफ द वायर इज अवे फ्रॉम द एक्सियल लोड. there is a distance, you can see there is a gap. So we have to see कि कितना amount of force ये exactly wire पे पड़ रहा है. Okay, so for that we'll just modify that. Modify कैसे किया हमने, उसको एक equal and opposite force लगा दिया. इक्वल एंड अपोजिट फोर्स लगाने से क्या क्या हो गया, इट इज वेरी वेरी सिंपल थिंग. नाउ इसका जो रिजल्टेंट है, ऊपर से एक डब्ल्यू नीचे से एक डब्ल्यू लगा दिया, इसको मॉडिफाई कर दिया. ये ऊपर से डब्ल्यू जो था उसने क्या क्या किया, ये जो नीचे वाला डब्ल्यू इसेंट्रिक डिस्टेंस पे था उसको मिला के एक टॉर्क बना दिया. ठीक है, और बचे वाला डब्ल्यू जो है यहाँ पे बच गया डब्ल्यू. सो दैट मीन्स वी हैव शिफ्टेड, ये जो डब्ल्यू था यहाँ पे हमने शिफ्ट कर दिया. शिफ्ट करते करते क्या हो गया, एक W डायरेक्ट आ गया और एक टॉर्क आ गया. ओके, ये जो टॉर्क है, ये टॉर्क क्या करेगा, इट विल ट्विस्ट, इट विल रोटेट द स्प्रिंग. स्प्रिंग वायर को रोटेट करेगा क्योंकि इट इज अ टॉर्क. टॉर्क होने की वजह से क्या गोल घुमाएगा उसको. सो इट इज अ टॉर्शनल शियर स्ट्रेस. और ये जो W जो है, दैट W इज गोइंग टू क्रिएट डायरेक्ट शियर. सो हियर टोटल शियर स्ट्रेस ऑन द वायर, जो वायर जो है जो हमें डिजाइन करना है उसमें कौन सा स्ट्रेस आएगा, शियर स्ट्रेस. डायरेक्ट शियर स्ट्रेस ड्यू टू डब्ल्यू, इसको कट करने वाला डायरेक्ट शियर स्ट्रेस एक आएगा. टॉर्शनल शियर स्ट्रेस ड्यू टू टी. सो देयर आर टू टाइप ऑफ स्ट्रेसेस. हमें जो जब वायर डिजाइन करना है, ऑन दैट वायर देयर आर टू टाइप्स ऑफ स्ट्रेसेस. फर्स्ट इज डायरेक्ट शियर स्ट्रेस ड्यू टू डब्ल्यू और एक ट्विस्टिंग. सो दिस टू काइंड ऑफ स्ट्रेसेस दैट वी हैव टू सी हियर. क्लियर. सो अब ये डायरेक्ट शियर स्ट्रेस कैसा निकालना है, टॉर्शनल शियर स्ट्रेस कैसा निकालना है, दैट विल सी इन द नेक्स्ट स्लाइड. क्लियर. नाउ stresses in the spring, total shear stress is equal to direct shear stress due to W and torsional shear stress due to torque. So total shear stress tau is equal to tau direct plus tau torsional. Now let us first think about the direct shear stress. जो नीचे से आ रहा है W load, उसका देखेंगे. It is a direct shear stress. So direct shear stress means this, it is just like a simple rivet is going to cut by shear, or we can say that it is simply जैसे आपण एखादी भाजी चिरतो, that kind of shear. So that is direct shear. So it is equal to force divided by area. How much force is there? So that means the direct shear stress is W divided by pi by 4 d square. So it comes out 4W pi d square. Okay. So here everyone, जितने लोग ऍक्टिव्ह आहेत त्यांनी काय करायचंय, यू पुट एव्हरीथिंग ऑन द पेपर. simultaneously you write everything, otherwise you cannot remember this. Okay, so direct shear stress equal to force divided by area. So area is pi by 4 d square because it is a circular wire असल्यामुळे त्याचा एरिया काय येणार आहे, pi by 4 d square. हे 4 वर गेल्यामुळे 4W pi d square हे डायरेक्ट शियर स्ट्रेस आला, जे की त्याच्या खालच्या बाजूने जो W दाखवलाय आपण त्या W चं. आता टॉर्शनल शियर स्ट्रेस प्लस टॉर्शनल आहे. when we say torsional means it is going to twist. तर आपल्याला माहिती आहे की इन आवर सिंपल शाफ्ट चॅप्टर मध्ये आपण काय केलं होतं, T is equal to tau pi by 16 d cube हे इक्वेशन घेतलं होतं. So here also same equation can be used because it is a twisting of shaft. ट्विस्टिंग ऑफ शाफ्ट असल्यामुळे इथे टॉर्शनलचं इक्वेशन घेतलं. टॉर्शनलचं इक्वेशन काय घेतलं? टाऊ टॉर्शनल इज इक्वल टू टी टॉर्क डिवाइड बाय पाय बाय 16 डी क्यूब. Here the torque is equal to force multiplied by distance. तर इथे तुम्हाला टॉर्क लिहिलेलं आहे, टॉर्क इज इक्वल टू डब्ल्यू मल्टिप्लाय बाय रेडियस. आता रेडियस किती असणार आहे? द mean diameter of the spring is d. Diameter d आहे. So radius is d by 2. So w into d by 2 is the force multiplied by radius. So that is torque. And pi by 16 d cube is the equation. So here this is d by 2. d by 2 असल्यामुळे हे 2 आणि हे 16 8 येणार. 8 वर जाणार. So 8 w d pi d cube. So this is the equation. This is the equation which is the equation of our torsional shear stress due to torque. So there are two equations. आपण इथे दोन equation separate घेतले. In this what wherever t is there, capital T is torque, W is load, D is the diameter of the spring, and small d is the diameter of spring wire. Diameter of the spring wire. So this is the equation. Okay. Now we'll think how we can add this together. Total shear stress काढण्यासाठी आपल्याला याला add कसं करता येईल. Okay. Let us go further. आपण पुढे पाहूया. Now the total shear stress is direct shear stress plus torsional shear stress. Here you can say T total is equal to 8WD divided by pi d cube, which is torsional, plus 4W pi d square, which is direct. Okay. So now here 8WD pi d cube plus, instead of 4W pi d square, I'll make some rearrangement. Rearrangement कसं करणार आहे मी? दोन्ही मल्टिप्लाय केलं, दोन्ही डिवाइड केलं. डी नी मल्टिप्लाय केलं, डी नी डिवाइड केलं. डी नी कॅपिटल डी नी मल्टिप्लाय केलं, कॅपिटल डी नी डिवाइड केलं. इट मेक्स नो डिफरन्स. तरी पण आपल्याला याला मॉडिफाय करता येईल. मॉडिफिकेशन कसं करता येईल? This 2 multiplied by 4, so it comes out 8. W, we can take d as it is. Pi, we can take this d here. So remaining is 1 by 2 because 1 2 is coming here. D by 1 because 1d I have taken here d cube. 1 by d because 1d I have taken here. So the common thing is 8WD divided by pi d square, which is also here 8WD divided by pi d square, pi d cube. So this 8WD pi d cube is common in between this. This is common. So here, by considering 8WD divided by pi d cube as a common, the remaining is 8WD pi d cube multiplied by remaining is d divided by 2d. So this is the equation. This is equation for torsional. This is equation for direct. Just we have modified. याला थोडंसं modify करून घेतलं आपण. Okay, so that we can make a common term. Common term घेण्यासाठी आपण ह्याला modify केलं. Okay. After this, let us go further. Okay. So next is now here. In this is torsional. This is direct. So I'll make 8WD divided by pi d cube common. ह्याला common घेऊन टाकून देऊ. So here it comes 1 because there is nothing. So it is 1 plus here d by 2d. If you just multiply this, it again comes same. Now here there is one term 8WD divided by pi d cube multiplied by ks. Whatever inside this bracket, we say that is one factor, spring factor. So spring factor is 1 plus d by 2d. So this is the equation. This is the equation which gives us total shear stress induced in that spring. Total shear stress induced in that spring. So you write this equation somewhere on your notebook, and this is very, very important equation. This equation is very, very important equation. Okay. So now after this, here we have considered everything is straight. आपण काय केलं? डायरेक्ट शियर स्ट्रेस मध्ये तो स्प्रिंग वायर स्ट्रेट पकडला, त्याला इक्वेशन लावलं म्हणजे शाफ्ट इज अ स्ट्रेट मीडियम. But inside the spring, everything is curved. It is not a straight. So that's why there is a AH wall. So the AH wall gives us some corrections in the equation. So Wall's correction factor is asked for 4 marks. In the Wall's correction factor, AH walls has considered the curvature effect. Okay. So you may find one question in your exam. Write about wall correction factor. So what is wall? Who is wall? Wall has given a simple correction. So what is that correction? The curvature of wire and its effect on the shear stress is considered by AH wall. The present equation of shear stress is modified to determine corrected shear stress factor, which is called Kw. So in the previous slide, you can see here Ks is equal to 1 plus d by 2d. In the previous slide, you can see here Ks is equal to 1 plus d by 2d. But this is for the straight bar. It is not for the curve bar. So Wall has corrected that by taking some experimental evidences, empirical relationship, and Wall has corrected one new term, which is the shear stress factor Kw. Now Ks is modified as a Kw by considering curvature of wire, because if there is a wire is curved, if the wire is curved, it will takes more amount of shear stress. Again, there is a fatigue failure is there. So all these things are considered by Wall, and he has modified that equation. Now modified equation is what? So modified equation is like this. So you can see here there is a Kw. What is Kw? Kw is the correction of curvature effect plus correction of direct shear stress. So here the wall correction factor Kw, which comes out 4c minus 1, 4c minus 4 plus 0.615 divided by c. In this, the first part here, this first part is the effect of curvature, and the second part is the effect of direct shear effect. Correction of direct shear effect. So Wall has corrected that Ks, and he gives us one more relationship. Now you write this equation somewhere, and this is the final equation which is generally we consider for our problems. And this is the final equation of stress inside the spring. Okay. So this is the equation, and here what is C? C is the spring index. So it is the ratio of capital D. Capital D means diameter of the spring. Small d means spring wire diameter. Okay. So spring index C. So Wall has given this equation in terms of C. Now here, this is Wall correction factor. Wall correction factor is asked for 2 marks, and equation can be asked for 4 marks. Now one more thing is important here. In our spring, the spring can be having different kinds of end. Sometimes the spring end can be plain end. So you can see the figure. You can see the figure. The first figure, in that there is a plain end. So plain end means here hello.
हाँ आवाज आ रही सर।
हाँ, so this is the second kind of thing. End correction में अलग अलग ends condition हो सकते हैं. In the spring there is a plain end. If there is no any grounding, उसको ground नहीं किया है, then total number of end dash जो term है active terms वो direct n ले सकते हैं. If it is a ground करने means इसको filing किया है, इसको कुछ flat किया है. If it is a grounded, कुछ flat रखने के लिए या फिर उसको उसका जो end है उसको फाइल करके उसको ग्राइंड करके ग्राउंड किया है, देन आल्सो इट इज एन. but if it is a square end, if I make that particular spring end as a square मतलब इसको 90 एंगल में कुछ टर्न अप किया है, then in that case the last two turns, जो last two turns है वो इनएक्टिव बनते हैं, इसीलिए क्या है उसको n+2 लेना पड़ेगा. ओके, और उसको स्क्वायर एंड ग्राउंडेड करेंगे है, और जो है टोटल नंबर ऑफ टर्न पे 2 ऐड करना पड़ेगा. सो दैट इज द मेन थिंग. सो व्हेन वी गो इन डिटेल एट द टाइम ऑफ आवर न्यूमेरिकल में इसका जब रेफरेंस आएगा, देन अगेन आई विल एक्सप्लेन इन डिटेल कि ग्राउंडेड है तो एन डैश कैसा लेंगे, स्क्वायर एंड ग्राउंडेड है तो कैसा लेंगे. ओके, सो दिस इज ऑल अबाउट आवर एंड कंडीशन. एंड कंडीशंस आर इम्पोर्टेंट when we take when we consider एक्टिव टर्न्स जो है सो जब हम स्क्वायर एंड करेंगे या फिर स्क्वायर एंड ग्राउंड एंड करेंगे तो एक्टिव टर्न जो है उसको माइनस करना पड़ेगा 2 से. ठीक है, समझो नंबर ऑफ एक्टिव टर्न्स 10 है और वो स्क्वायर एंड ग्राउंडेड है, तो उसमें ऊपर का और नीचे का जो है वो 2 टर्न जो है वो 2 टर्न उसमें काम नहीं करेंगे. दैट मीन्स टोटल नंबर ऑफ टर्न विल बी 10+2. ओके, क्योंकि दो ऊपर के और नीचे के जो स्क्वायर एंड है वो तो लोड नहीं लेंगे, तो उसको दैट इज द मेन थिंग. ठीक है, सो नेक्स्ट टू दैट लेट अस हैव वन सिंपल न्यूमेरिकल बेस्ड ऑन दैट. ठीक है, एक न्यूमेरिकल देखते हैं. सो न्यूमेरिकल इज इन फ्रंट ऑफ यू. Such type of numerical is asked for 4 marks. A closed coil helical spring is used for front suspension of an automobile. It's a closed coil spring which is used for automobile. The spring has stiffness of 90 Newton per mm with square and ground end. The load on the spring causes a total deflection of 8.5 mm by taking permissible shear stress of 450 megapascal. Find the spring wire diameter. Assume spring index as a 6. So this is a very simple problem here. So this can be asked for 4 marks. Very simple basic type of problem. Tomorrow we'll go for here there is a wall correction factor 1.25 450.25. Now we know that by using our simple equation, the total shear stress is 450 megapascal, which is equal to 8 WD divided by pi d cube into kW. In this, we know we don't know only the wire diameter. So 8 W is 765 multiplied by capital D. We know the C. C is equal to D by D. So C equal to capital D by small d. So we can put here 6 multiplied by D. So 6 is the value of C. C into small d divided by pi d cube into 1.2525. So this is very simple equation. If you put just this value and if I equate it to 450 megapascal, then we can get the simple D, which is equal to 5.7 mm or 6 m. So this is direct to direct numerical without without any complication. We can find the diameter here. So this completes one equation in which we find the relation between the total shear stress and the diameter of the wire.